بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. النهاردة بنتكلم عن second lesson pressure. The first, pressure at a point. Pressure at a point is the average normal force acting on unit area at this point. Is the normal, the perpendicular force that act on unit area of this point. There are three cases for the acting force. The force may act normally on this point, or the force may incline on the point and make an angle theta with the horizontal, or incline and make an angle theta with the vertical axis. At the first, if the force acts on the point normally or perpendicular to the point, then the pressure P equal F over A. P equal F over A. Second case, when the force acts and makes an angle with the horizontal axis, then by resolving the force into two components, Fx and Fy. Here, Fx is F cosine theta and Fy is F sine theta. According to the definition, what is the normal force that acts on this point? What is the normal component that acts on this point? It is Fy, F sine theta, then P equal F sine theta over A. Second case, when the force makes an angle with the vertical, by resolving the force into two components, Fx and Fy, where Fx is F sine theta and Fy is F cosine theta. Also, what is the normal perpendicular force that act on the point? It is Fy that is equal F cosine theta, then the pressure equal F cosine theta over A. Let's take an example, simple example. A child that acts on 2 points, 2 area, and this child is acting on 1 area. What is the greater pressure? Which pressure is more than the other? From the relation, pressure is inversely proportional to the area. By increasing the area, the pressure decreases. Then, in the first case, pressure is less pressure, while the second child acted by high pressure because here is the 2 points increasing the area, while in this case, this one point, the area decrease, then the pressure increase. In the second case, if the hammer acting on the nail, the hammer acts on the nail by an angle. The hammer acts on the nail by an angle. The force of the hammer, F, that makes an angle theta with the horizontal plane. By resolving the force into two components, Fy and Fx, Fy and Fx, Fy, Fx, Fx F cosine theta, Fy F sine theta. What is the normal force act on the nail? It is F sine theta. Then by acting the relation, pressure equal F sine theta over A. In the third case, this box is sliding on an inclined plane to reach this point. What is the force that acts by this box on the inclined plane? Is the weight of the box. Weight is a force. Weight is a force. So by resolving the weight into two components, the first Fy, the second Fx. Fy equal F cosine theta, Fx equal F sine theta. What is the normal component? What is the normal component? It is F cosine theta. Let's ask about the force. In the first case, the pressure, here is less pressure, وهنا more pressure. But the force of the child that equal to the weight of the child, that is equal to mass times gravity, is constant. Is what? Is constant. Okay? Like this box. the force in the inclined plane is the weight equal m dot g. Type, when the box reach this point, what is the weight of the object? The weight of the object also equal m times g, and the weight is constant. Then the pressure decrease, the pressure increase, because the area differ from one case to another case, but the force that is equal to the weight of the object, that is equal to m times g, is constant, and the weight of the box is constant in the case of inclination or in this case. Weight is directly proportional to the force. Pressure is directly proportional to the force. Then the relation between the pressure and the force is directly proportional, and the slope equal P over F, that is equal 1 over A. And the relation between pressure and the area is inversely proportional. Then the relation between force and the pressure is directly proportional, and the slope equal what? Slope equal area, because F divided by pressure equal area. Then the relation between the pressure and the 1 over area is directly proportional, and slope equal to F. Since pressure equal force divided by area, then the measuring unit of force is Newton, and the measuring unit of area is meter square. Then the unit of measuring pressure is Newton per meter square. Newton per meter square. There is another unit for the pressure. Since Newton equal to kilogram meter per second square, and we know that the previous year, and equal to joule per meter square, joule per meter. By substituting this unit in the basic unit of pressure, then kilogram meter per second square divided by meter equal kilogram per meter second power of 2, and can be written by kilogram meter negative 1 second negative 2. Also, by substituting the unit joule per meter in this basic unit, then joule per meter over meter equal to joule per cubic meter. Joule per cubic meter. Or the measuring unit of pressure is Pascal. We have 4 units for measuring the pressure. Pascal, joule per cubic meter, kilogram per meter second power of 2, or the basic unit is Newton per meter square. Again, pressure equal F over A, and the units is Newton per meter square, joule per cubic meter, kilogram per meter second power of 2, or Pascal. Pressure is directly proportional to the force, and the pressure is inversely proportional to the area. So heavy trucks have wide multiply number of tires. Heavy trucks have wide tires, and they multiply number of tires Y to decrease the pressure exerted by the heavy load of the truck on the road. By increasing the area of the tires, the pressure decreases. Needles and pins have sharp edge. Needles and pins have sharp edge, small area, and large pressure to be easy to penetrate the object or the body. When the area decrease, the pressure increase, so it's easy to penetrate the body. Let's take an example. From the opposite figure, if the gravity equal 10 meter per second square, find the density of the cuboid, find the maximum pressure of the cuboid on the plane, and the minimum pressure of the cuboid that act on the plane. To change its position, to find the maximum pressure and the minimum pressure. At the first density, density rho equal mass divided by the volume equal the mass is 1 kilogram divided by the volume is the dimensions of the cuboid 2.5 times 5 times 10 centimeter times centimeter times centimeter cubic centimeter times 10 power negative 6 to change from cubic centimeter to cubic meter. Then the density of the cuboid is 8,000 kilogram per cubic meter. To find the maximum pressure on the plane, pressure maximum equal the exerting force of the cuboid on the minimum area, the least area, the least two dimension. What are the least two dimension? 5 and 2.5. Then the force of the cuboid equal its mass times the gravity. The force is the weight. Then the force equal the weight. Force equal the weight m times g divided by the minimum area equal mass 1 times the gravity 10 divided by the minimum area. The least two or the smallest two dimension is 2.5 times 5 times 10 power negative 4. 2.5 centimeter times 5 centimeter square to convert it to meter square times 10 power negative 4. Then the minimum pressure is 8,000 Newton per meter square. The minimum pressure on the plane, pressure minimum equal the force acting or exerting on the maximum area, the largest two dimensions of the cuboid. Then mass times gravity divided the maximum or the big two dimension. Then 1 times 10 divided by 5 times 10 times 10 power negative 4 equal to maximum pressure. Let's calculate the maximum pressure. 10 times 1 divided by times 10 power negative 4 equal to 2,000 Newton meter power of 2. There is another way to find the maximum pressure and the minimum pressure. To find the maximum pressure equal rho hg. Pressure directly proportional to the height. يبقى the maximum pressure, the maximum height. What is the maximum height of cuboid? The maximum height of cuboid is 10. Then equal to rho density 8,000 times 10 power negative 2 times the gravity 10 equal 8,000 Newton meter power of 2. By another way to find the minimum pressure B minimum equal rho hg. H minimum, the smallest dimension, equal 8,000 times the smallest dimension 2.5 times 10 power negative 2 times the gravity 10 equal 2,000 Newton meter power 2. There is another way to find the minimum and the maximum pressure. From where we get rho hg? Rho hg. Since in the force equal mass times gravity, and the mass equal rho volume times gravity equal rho ah, since in the volume equal area times height times gravity, then the pressure that is equal force over area equal rho ahg divided by area. Cancel area with area, then the pressure equal rho hg. This is another formula for the pressure. From the figure, find the total mass of the child. A child is standing on the chair, and the total mass of the chair and the child is 100 kilogram, where the chair has a circular leg. Circular leg of radius 0.4. What is the pressure produced by the four legs on of the chair on the plane? So the pressure equal force over area. That is equal to mg divided by area. The mass of the child and the mass of the chair is 100 kilogram, but the four legs only that acts on the plane, surface plane. Then that is equal to m times g divided by 4. The total mass divided by 4 divided by the circular, the area of the legs, equal, the mass is 100 times the gravity equal 10 divided by the 4 legs over the area of the leg. It is a circular leg. Then the area of the circle equal by r square equal 1000 divided by 4 divided by radius equal 0.4 centimeter times 10 power negative 2 all power of 2. Then the pressure equal to, let's calculate it, pressure equal to 1000 divided by 0.4 times 10 power negative 2 all power of 2 equal, pressure equal 4.9 times 10 power of 6 Newton meter square. Why we divide the total mass or the total weight divided by 4? Because the total weight of the child and the chair is divided on the 4 legs of the chair that is contact with the plane. That is contact with the plane. The pressure is the force that act on the area contact with the plane, not the total weight of the chair and the child. We have 2 applications for pressure. The pressure of air in car tires. The pressure of air in car tires by increasing the pressure of air inside the car tires, the area of the tires that is contact with the road decrease, so the friction force of the car decrease, so the temperature produced decrease. Again, the pressure of air inside the car tires, when the pressure increase, the area of the tire decrease, so the friction force between the tires and the road decrease, and also vice versa. By decreasing the pressure of air inside the car tires, the area of the tire became more flattened and increase in contact with the road, so the friction force increase, so the temperature of the tire will increase. Number 2, from the applications, the blood pressure. The blood pressure. We have 2 types of blood pressure. We have 2 types of blood pressure. Systolic pressure, contracting of the heart to pump the blood all over the body parts, that is equal to 120, and the diastolic pressure of the blood, relaxing pressure, that is equal to 82. So the normal blood pressure is 120. 82 indicates torsielli or millimeter mercury. We will take it in the in the next lesson. 120, 82, systolic and diastolic pressure. Second point in this lesson is the pressure at a point inside a liquid. Pressure at a point inside a liquid, not a pressure at a point on a plane like we told you before. Let's draw a container that contains a certain liquid. At the point at the base of the container, what is the pressure exerts the point or acts on the point inside the container? It is the weight of the liquid column above this point. The weight of the liquid column above this point. Okay, then the pressure exerted on the point inside the liquid is the weight of the water or the liquid above this point. Then pressure, since in the pressure equal force over area, and the force is the weight mg, then pressure equal mg divided by A. Since in the mass equal rho volume, then the pressure equal rho volume gravity divided by area. Since in any volume equal area times height, then the pressure equal rho A hg divided by A. Cancel A with A, then the pressure equal rho hg. Rho hg, density of the liquid, height of the liquid, the gravity. Density of the liquid, height of the liquid, and the gravity. This is the container if the container is closed. But if the container is opened and exposed to the atmospheric pressure, BA, atmospheric pressure, then the point inside the liquid will exert by two types of pressure: the pressure of air and the pressure of the liquid, the weight of the liquid above this point. Then pressure equal BA plus rho hg. يبقى pressure equal rho hg when the container is closed. Pressure equal PA, atmospheric pressure or the air pressure, plus rho hg when the container is opened. So what is the relation between each quantity and the pressure? Pressure, height, directly proportional. By increasing the height, the weight of the liquid increase, so the pressure increase, and the slope equal rho g. Second relation, pressure and density. By changing the liquid and increasing the density of the liquid, the pressure increase and the slope equal hg. The relation between pressure and the gravity is directly proportional also, and the gravity differs slightly from one position to another position all over the earth or at the earth's surface, because at the equator the gravity equal 9.7, approximately 9.7, and at the two poles the gravity equal 9.8 or reach 10.2 meter per second square. Why? Because the distance from the center of the earth to its surface is 6,370, and from the center of the earth to the two poles 6,358 or 50, approximately 58 or 50. When the distance between the center and the surface increase, the gravity decrease. When the center between the distance between the center and the surface of the earth decrease, the gravity increase. Right. The relation between pressure and the height, where the straight line intersected the y-axis. This point indicates atmospheric pressure. This point indicates the y-axis indicates pressure, and the atmospheric pressure is a type of pressure. Then the point of intersection of the straight line with the y-axis is the atmospheric pressure, and the atmospheric pressure equal 1.013 times 10 power of 5 Newton meter square, or joule per cubic meter, or kilogram per meter second power of 2, or Pascal. All the units are equivalent to each other. And the slope equal also rho g, Okay. طيب. Let's talk about another point. Why the dams are designed so that it is thicker at its bottom. The dams are designed thicker at its bottom. Why? This is the level of water, and the dam is built here so that it is built so that the wall is thicker at the bottom. Why? Because by increasing the depths of water, the height of water, the pressure increase. The dams are thicker at the bottom because the pressure increases of water, because the height increase, so the pressure increase. Another point, from these three different containers, what is the pressure acting on the three different containers? The pressure here is the same. Although they are different in the cross-section area of each container, the pressure is equal. In the three containers. Why? Because pressure doesn't depend on the area. Pressure at a point inside the liquid, or acting on the base of these three containers, pressure equal rho Hg. And from the previous relation, we cancel area with area. So pressure doesn't depend. Pressure at a point inside the liquid. Pressure at a point inside a liquid, not the pressure acting on the plane, on the horizontal plane. Pressure at a point inside the liquid doesn't depend on the area of the container. Pressure only depends on height, density, and the gravity that differs slightly from a place to another place. So from these three figures or three different shape, the pressure is equal in all of them, because the height of liquid is equal in all of them. يبقى height of the liquid is equal, but the force acting on the base of each container different. The force of liquid acting on the first container, the time is gravity. Since in weight equal mass times gravity, then the weight of the liquid equal the force of the force of the liquid that presses on the bottom of the container. In the second conical flask, the weight of the liquid, the total weight of the liquid, is greater than the force of the liquid that acts on the container. In the second, the total weight of the liquid is less than the force acts on the base of the container. The total weight of the liquid is less than the force act on the container.